Hello everyone, and welcome to the continuation of our unit on exponents. Today we're going to look at two properties, the zero and negative power properties of exponents. Okay, so we're going to use what we know already about some exponents to kind of extend some patterns and kind of dive into an area where we haven't explored yet. So we know 2 to the 5th power is 32, 2 to the 4th power, okay, that's 16, 2 to the 3rd power is 8. I'm going to pause for a second to kind of show that I've been dividing by 2 as I've been coming down here because there's one less power of 2 that I'm multiplying. Okay, so 2 to the 2nd is 4. Yep, again, I had to divide by 2, kind of I'm following my downward pattern. 2 to the 1st, well, that's kind of silly to write, but that's just 2. Again, we divided by 2. Well, if I'm looking at my exponents went 5, 4, 3, 2, 1. So next up would be 2 to the 0. That's pretty weird. How do we begin to do that? How do we multiply 2 by itself 0 times? Well, by definition, and if we kind of follow the pattern over here, we need to divide by 2 again. So 2 divided by 2 is 1. Interesting turn of events here. So we've got 2 to the 0 is equal to 1, and in general, that's our first rule, is that anything, x, raised to the 0 power is 1. It could be 5 to the 0, that's 1. 6 to the 0, that's 1. X to the 0, that's 1. Anything to the 0 power is 1. But we can go further. If we keep our exponents going down, next would be 2 to the negative 1. And so if we divide 1 by 2 again, we get a half. Ooh, interesting. 2 to the negative 2 would be next. A half divided by a half is a fourth, or a half times a half. Or, yeah, not a half. A half divided by 2 is a fourth, which is a half times a half. And then we'd get negative 3rd power, and that would be 1/8. Very interesting. Now, we certainly can simplify these ones like this, but we also want to kind of show that this is 2 to the 1st power here. This 1/4, that's the same as 1 over 2 squared. And the 1/8 is 1 over 2 to the 3rd. That's really what I want over here. 1 over 2, 1 over 2 squared, 1 over 2 to the 3rd power. And so when we see this, we kind of see our exponents went from negative exponents to positive exponents, but when they did that, they moved to the denominator in this case. So that's our second rule. If we have x raised to a negative power, negative n, that's going to be equal to 1 over that same base raised to the positive n power. Okay, so let's look at some examples and use our two new rules. All right, so we're going to rewrite the following without using negative exponents. In general, simplification of things with exponents, you always want to eliminate negative exponents. That's considered more simplified. So 3 to the 3rd, we can rewrite that as 1 over 3 to the positive 3rd. So the exponent moved it to the bottom here, and it became positive. Now, we can evaluate this, and for reasonable numbers we will. So that's 1 over 27. Great. Here we have 6 times 5 to the negative 2. So we'll get to the 6 next. But 6 times 5 to the negative 2, that's 1 over 5 squared. Great. Again, negative exponent moved to the bottom, became positive. So 6 times, we can make that 6 over 1. 6 times 1 is 6 over 5 squared is 25. And there's our answer. If we just have a variable, k to the negative 9, well, as we did before and as our rule stated, that's going to be 1 over k to the positive 9. Can't simplify that any further, but now it has a positive exponent, so we like that better. Okay, a problem like number 4 will throw people off because we see 5m to the negative 3rd. You have to remember this negative 3 is only connected to the m. The 5 is not getting raised to that power. Order of operations said we would do this exponent first, then we'd multiply by 5. So the 5 kind of stays by itself, and we would make this 1 over m to the 3rd. Now, we're going to clean this up a little bit. Since that's 5 over 1, we're going to go ahead and multiply the numerators together to get 5 over m to the 3rd. Great. Now, if we compare, and I'll erase it so we can see clearly, this one, number 5, to number 4. So number 5, notice the 5 and the m are in parentheses, and that parenthesis is raised to the negative third power. So this time, since that whole thing is to the negative third power, that whole thing moves to the bottom to the third power. There is ways to simplify this further, but we haven't really done that yet in class. You might, be able to kind of recognize that something to the third power just means multiply it by itself 3 times. And so if you think about it like that, you could kind of recognize that that's 1 over 5 times 5 times 5 is 125 m to the third power. But for right now, this is as simplified as as we need to go. Our rules will help us get here a little quicker in the future. All right, this next one, again, 5 is to the negative third. The m here is to a positive third, so he doesn't move. So what I like to do in a situation like this is just kind of put my fraction line down first, and then I start picking what goes where. So negative exponents are what are going to move. So the 5 to the negative third goes down here as 5 to the positive third. Now the m to the third, this is really like a fraction over 1 to start with. So it's in the numerator, so it stays in the numerator, m to the third, and then we'll clean this up as m to the third over 125. Great. Let's look at a few more examples. Again, even though now it's in the denominator, the m to the negative third is not attached to the 5. So we have, I'm again going to put my fraction line here. The 5 stays. The m to the negative third moves to the top as m to the third. Great. If something's in the denominator already, I guess what we're getting at, it's going to move to the top. So it's always going to move sides. Negative exponents can move to the top if they're on the bottom to begin with. So here, 2 to the positive third over 1. So we can then simplify that as just 8. Great. Whoa, number 9 has 2 negative exponents. Again, draw your fraction line first and then think about where things are going to go. The 3 to the negative second, we can put them on the bottom as 3 to the positive second. Negative exponent told it to move to the bottom. And this, which is on the bottom now, 2 to the negative third, comes to the top as a positive exponent. And then we can simplify that as 8 over 9. Terrific. We'll leave a couple of these for you, but watch out for things to the 0 power. This is the easiest problem we've done yet. Anything to the 0 power is 1. So, great. We're also going to talk about something called expanded form. So, consider the number 4,253 is 4,000, 4 from the thousands place, plus 200 plus 50 plus 3. So great, we can split it up and have it added like that. Well, how can we represent 4,000? Well, 4,000 is 4 times 1,000. 200 is 2 times 100. 50 is 5 times 10. And 3 is 3 times 1. Well, let's continue to take this a little further. 1,000 is 10 to the third power. 100 is 10 squared. 10 is 10 to the first power. And 1 is 10 to the, oh, that's right, 0 power. Anything to the 0 power is 1. So this is what we would now consider exponential expanded form. So we'll try another one, 40,309. So we've got a 4, and it's in the 10,000s place. So we're going to multiply that by 10 to the 4th power. And you can kind of really think about it. The first place here is 0, 1, 2, 3, and then this is in the 4th power of 10. Okay, and then we're going to add to that. We don't have anything in the power of 10 to the third power, so we skip over that. We go to 3 times 10 to the second. Again, we don't have anything 10 to the first power, but we do have plus 9 times 10 to the 0 power. So that number is now written in an exponential expanded form. A couple more fun examples for us. Let's do this first one here together. So we've got 98,000, so that's 9 times 10 to the 4th, plus 8 times 10 to the 3rd, plus 7 times 10 to the 2nd. We don't have anything times 10 to the 1st, but then we have 6 times 10 to the 0. Terrific. Leave a couple more examples there for you to work out. Uh-oh. Very similar to before, but now we've got a number that's less than 1 or has decimal number parts to it. So 4.4253, or 4,253 10,000ths, can be represented as 4 tenths plus 2 100ths plus 5 thousandths plus 3 10,000ths. Well, 4 tenths is 4 times 1 tenth. 2 hundredths is 2 times 100th. 100th. 5 thousandths is 5 times 1 1,000th. And 3 10,000ths is 3 times 1 10,000th. All right, so we can now represent these with powers of 10. So this is 10 to the negative 1, 10 to the negative 2, 10 to the negative 3, and 10 to the negative 4. Awesome. So let's now look at a whole set of numbers like this and rewrite them in exponential expanded form. So 0.2056, well, that's 2 times 10 to the negative 1, plus, we have none in the 10 to the negative 2 power place there. We have 5 times 10 to the negative 3, and we have 6 times 10 to the negative 4. Terrific. Let's skip around here. Let's try number 19, which has whole numbers, but also parts that are greater than 1, but also parts that are less than 1. So we've got 3 times 10 to the first power plus 4 times 10 to the 0 power, plus we have nothing times 10 to the negative 1, but we have 2 times 10 to the negative 2. So we can represent an entire number as a product of numbers times 10 to different exponents. Great. All right, so here's now a number written in exponential expanded form, and we're going to write it as a decimal number. So the best way is to start with our highest power, and so we have a 3 there, and it's 3 times 10 to the 5th. So this is in the highest place, and so we're going to basically leave, okay, there's some missing numbers between 5 and 2, so we don't have anything 10 to the 4th or 10 to the 3rd. So we're going to leave zeros in those places, and then we've got a 4, and then we have nothing in the 10 to the 1st, nothing in 10 to the 0, but then we do have our decimal point and 6 times 10 to the negative 1, nothing in the 10 to the negative 2, and we have a 7 in the 10 to the negative 3. So we can write whole entire numbers back into decimal form from expanded exponential form. Okay, don't be afraid of fractions. So first off, still anything, even a fraction, raised to the 0 power is 1. Now, if we have a fraction raised to a negative power, the negative power, as we've seen so far, has been taking things from the top and sending it to the bottom. It's been basically taking reciprocals of things. So 1/2 to the negative 1 is the same thing as 2 over 1 to the positive 1. We flipped our fraction, made our exponent positive now, and we got rid of our negative exponent. And then we could simplify this to make it just 2. So here, again, we take the reciprocal, 3/2, and now it's to the positive 1. If we've got a number raised to a negative 2 power, when we flip the fraction to make it 2 over 1, we just make that a positive 2. So that's 2 squared, or 4. And here, 3/4 becomes 4/3, now to the second power, which is 16 over 9. Great. So what about some of these examples here? 1/2 raised to some power is 8. Well, that is kind of like 8 over 1. So to me, I'm seeing 2 on the bottom becomes 8 on the top. So that tells me right away that m must be negative. So a negative exponent would take the 2 from the bottom and move it to the top. And to take a 2 to make it go to an 8, we would need the third power. So m must be negative 3. We have something, we have 1/2 raised to some power equals 1. And you might start guessing, check, oh, okay, what number? Oh, that's right. Anything raised to the 0 power is 1. So m is 0. All right, here again, we see 2/3, and I see 9/4. You hopefully can draw some connections that 2 and 4 somehow are connected, and 3 and 9 are somehow connected. So we must have taken the reciprocal at some point. So m must be a negative number, and to go from 2 to 4 and 3 to 9, it must have been negative 2. Here, 2 and 4, 5 and 25, there's no reciprocal that took place, so we don't have a negative m. M is just 2. But then here again, 3 and 27, 4 and 64, those are clearly a sign that we took the reciprocal. So it's a negative m, and it's a negative 3. Great. All right, so we have a whole bunch of problems to practice here. I'm just going to hunt and check out a few of them here. So let's look at number 30. Again, what I like to do is I like to start by drawing my fraction line if I can see something's going to be in the denominator. So I go through piece at a time. So the 8 doesn't have a negative exponent, so it stays on top. The x doesn't have a negative exponent, so it stays on top. The end of the negative 13, negative 13, move to the bottom, now it's 13. And that's our answer. Great. Now here, everything is raised to a negative power, so we just have 1 over 8 x, and all in parentheses still, to the 13th power. All right, when I see 32, I see, okay, I'm going to draw my fraction line. 8 stays up top. X to the negative 6 moves to the bottom as x to the 6th. Y to the 4th stays up top where it originally was. Okay, let's do 33 just to make sure we're clear. We have 2/3, and then w to the negative 11th would be 1 over w to the 11th. So we're just going to clean that up a little bit and make that 2 over 3 w to the 11th. So just multiply that fraction by your reciprocal of w to the 11th. So, okay, great. All right, let's hunt down. Yeah, let's do a problem like 38 over here. All right, so I see in front here is a negative 3. That is a negative number, not a negative exponent. So be careful, that sometimes throws students off. The x to the 8th, he's going to stay. Now I'm going to go to the bottom and look to see if everything's staying there. So on the bottom I see 2 to the negative 4th. That's a negative exponent. That means it comes up. So that's going to be 2 to the positive 4th on the top. And y to the negative 3rd comes up as y to the 3rd. So there's actually just 1 left on the in the denominator. So nothing will need to stay there long term. So we can go ahead and take negative 3, and we're going to multiply that by ultimately 2 to the 4th, which is 16. So we have negative 48 x to the 8th y to the 3rd. And that's our final answer there. So the rest of these problems here, continuing through page 8, should be fair game. Maybe we'll just try to find 1 or 2 more that look like a lot of fun for us that we can go over. Let's just look at like number 60 here together. Looks mean and evil. It's not so bad. So I see negative 3 up here and 12 down here. Well, that's a fraction still. So I'm going to go ahead and throw my fraction line there, but I'm going to simplify this fraction. Negative 3 and 12, that would be negative 1 over 4. Great, so I took care of the coefficients out there. Now let's see where everything should end up. So a to the negative 2nd. I'm going to go ahead and just take him and put him where he belongs. He belongs in the bottom now as a to the 2nd. B to the 5th, he should stay because he's a positive exponent. C to the negative 13th, let's get him down to the bottom where he'll be positive. And that's the entire numerator. So we go back down to the denominator. We got rid of our 12 already. X to the 2nd, he stays. Since he's a positive exponent, he doesn't move. I know sometimes people say, oh, it's a positive, that means it goes on top. No, a positive means it stays where it is. So it's positive, it stays put. The y to the negative 5th, he's going to move and come up top as a positive y to the 5th. And z to the 8th, also positive exponent, so he stays. So that right there will be our final answer.